Alright, let's get started. I'm Drone Guy 26 and this is the Guitar Hero on Tour Modern Hits custom song tutorial. I'm making this tutorial not just because I want to share this with the community, but because I need the community's help in further developing customs. I can only do so much as one person, and so all of my scripts will be uploaded to a GitHub link in the description, as well as all of the other documentation that I found regarding customs. What's specifically needed, I will go more in depth later on in the tutorial. Just know for now that it isn't completely finished, but customs are in a completely playable state right now. In case that wasn't any indication, this guide will be an in-depth tutorial on not just how to import customs, but on the game itself and how it handles song and chart files. So, if you want a briefer overview, please go to this timestamp. So let's start with a general overview of the two processes, and just a general outline so that we know what we're doing when we get to each of the individual steps. The full list of programs you need installed to perform these edits is as follows: Moonscraper, Python, Crystal Tile 2, Audacity, Sox Sound Exchange, and a hex editor of your choice. I like to use HXD. Optionally, you can install VGM GUI and Decime to make testing your ROMs much easier. We're going to start with the chart format that everyone knows and loves from Clone Hero and GH3, and we're going to pre-process it using the script that I wrote. Then, we're going to run that script to create the uncompressed hex data. That hex data is going to be fed into a compression algorithm, and we're going to attach a header after the compression algorithm so that the game is able to understand the file. And finally, we're going to be able to insert the chart into the game's ROM itself. For the audio, we're going to edit the sampling rate and mix with Audacity, encode it to the raw format using Sox Sound Exchange, attach a file header, and then use another script to attach several smaller headers to blocks within the raw data, and finally, insert the audio into the game's files. Each node in a chart is represented by 8 bytes. The first 4 bytes represent the offset of the note in milliseconds. The next 2 bytes represent the length of the sustain in milliseconds. The next 2 bytes represent information about the color of the note, whether or not the note is a hopo, or if the note is a star power. These last 2 bytes are what needs the most research currently. Let's go into how it works. Every note starts with a base value of 0x10 or 0x20. These values are used by the game to determine which player should be playing in face-off mode in multiplayer, but because we're only going to be playing single player, we can start off with a base note of 0x10 for every note. All of these values are additive, which means if we want a note to have a certain property, we simply add the value of this property to the note's information value. So if we want the note to be a hopo, we will add 0x40. If we want the note to have a green gem, we will add 0x100. If we want it to be a red gem, we can add 0x200. If we want it to have a yellow gem, we add 0x400, and if we want it to have a blue gem, we add 0x800. This is what allows chords to be stored in the same amount of bytes as regular notes. I figured out these values with the help of LordMao5, and also looking through the hex data of a decompressed version of Shockwave. Star power is also contained in this note property, but I'm not sure what the values are supposed to be for it. It's either 0x01 or 0x08, and then you add another value to indicate that it's the end of a star power phrase. This is really what needs some research effort. The game applies the file extension QGM to these chart files, but it's rather arbitrary because it's just hex data, but I'll be referring to the game's chart files as QGMs for this purpose. So, in order to turn your formatted 4-fret chart into a QGM file, you will place your chart into a folder with convert.py, which is what my script is called, In addition to this, you will also need to have the Python library chparse either installed or located in the same directory as convert.py. The GitHub link is in the description, along with all of the other programs. Make sure that your file is named notes.chart. That is what the script is looking for. It's on line 141 if you really want to change it. Then open up a command line, navigate to that folder, and run python convert.py. This will not modify notes.chart, and instead will spit out another file called chart.qgm, which is what we're looking for. Well, great, now we have the QGM. What do we do with it? This is where most of the people on Score Hero were stuck, because the DS required this to be compressed, and they were not able to figure out the compression because of this weird 8-byte header that was messing them up and causing all of the compressors not really to work. What I found out is if you simply ignore that and just add the header later, it completely works. So, in order to compress it, we are going to need to open up Crystal Tile 2. And in Crystal Tile 2, we are going to go to Tools, LZ77 Huffman Data Compression. Then we are going to open up our file and save it with the default LZ7710 VRAM settings. It'll save with the .lz77 file extension, but remember, that doesn't matter because all we care about is the hex data. It's ironic that all of this fuss was made over writing a recompressor when it was all hidden under our noses the whole time. The compression is the exact same compression, only missing the 8-byte header. So all we have to do now is add this 8-byte header. So what we're going to do is we're going to open up your favorite hex editor. Once again, I like to use HXD. And we're going to pad the end with zeros until it's a multiple of 4, and then note the file size. This is because the DS reads data in 4-byte words, and so if it doesn't end on a multiple of 4, it throws off the entire rest of the ROM. Once we have that file size noted, at the very beginning of the file, we're going to insert the bytes 4C 080045, and we're going to follow that with the little endian hex value of the quantity of the file size that we just computed, plus 8. This file size information takes up 3 bytes. Once you get those changes saved, congratulations, you now have a chart that works with Guitar Hero DS. Alright, it's time for the part that gave me the most pain. The audio. Audio in Guitar Hero On Tour is contained in 3 different files. There's guitar.ogg, rhythm or bass.ogg, and song.hwas, or HWAS. Although it may seem simpler to replace the OGG, because that's what a lot of programs can save as, I found it more worth it to replace the HWAS. So that way, when you miss a note, it doesn't cut out the audio. Furthermore, from the testing I did with replacing OGGs, it didn't actually load correctly, and I wasn't able to get a good result out of it. Here's a little bit more information about the HWAS files. It is a arbitrary file format used by Vicarious Visions in multiple of their games. It was used in a Star Wars game, I think, and also Over the Hedge. It consists of a 512-byte header, which is fairly easy to replicate. We'll be doing that later. And then the actual raw data is encoded in raw IMA ADPCM audio. This audio is grouped into groups of 32,768 byte blocks, or to make that more simple, 0x8000 in hex. The first 4 bytes of these blocks are used as a header, and this header is used to compute the volume of the block. and this is currently the largest issue with customs on DS, because when we encode the audio into IMA ADPCM, it does not compute these headers for us, and so the audio will get quieter and louder, seemingly random from what I've seen. Sometimes it'll get quieter in the loud parts and louder in the quieter parts. It's really dumb. So this is where I probably need the most help from the community. The best way, I think, to go about it is the program VGM Stream is able to perfectly decode HWAS files. And I've been using a GUI version of it, VGM GUI, in order to test HWAS files and see how they sound before importing them into my game. So I was thinking, if it decodes them perfectly, can we figure out how to re-encode based off of that code? I'm currently waiting on a reply on a forum post, but if somebody more experienced in reading that kind of code could try and decipher a better way to re-encode it based off of the source code of VGM Stream, which I have linked in the description. Currently, I just have a script that inserts a static header every 0x8000 bytes, so like it turns out okay, but it's not nearly what it could be. In order to get a good result with the HWAS files, though, we're going to have to deal with some strange things. First off, we're going to need to import our song audio into Audacity and change the project rate to 19,996 Hz. Then you're going to go to Tracks, Resample, highlight the entire portion, and you're going to resample the audio to 19,996 Hz. Finally, you need to go to Tracks, Mix, and then mix stereo down to mono so that you have a mono track at 19,996 Hz. Finally, we're going to export it as a WAV file. Alright, so with this WAV file, we are going to open up a command line and navigate to where the WAV file is. And with SOX Sound Exchange installed and added to the system path variables, you're going to write SOX song.wave song.ima. And what this will do is it will turn your song.wave file and re-encode it as raw IMA ADPCM. So now, with the IMA file, we need to add the header so that we can change it into a HWAS file. So, once again, we are going to open up your favorite hex editor. Once again, mine is HXD. And we're going to go to the end of the file and note the current length of the file as it is right now. And then you're going to pad the end with zeros until the next byte is a multiple of 0x200. So your final byte is going to be something something FF, and so the next byte is a multiple of 200. With that done, you're going to insert 512 bytes of just zeros at the beginning of the file. This header information is kind of hard to understand, so hopefully this thing that I found on the Score Hero threads helps a bit. The first 4 bytes are going to be the letters HWAS written in little endian, so SAWH. The next 4 bytes is going to be the memory allocation length. It's going to be 32,768, so that'll just be 00800000. The next 4 bytes starting at 0x8 is going to be the sample rate. I'll have it on screen here. The next 4 bytes is going to be the number of channels, which is always going to be 1, so 0, 1, 0, 0, 0, 0, 0, 0. Next is going to be the start of the loop, and it's just going to be 0, so you're going to have another 4 bytes of zeros. And starting at offset 0x14, this is where that first number that you noted, the file size before padding, that's where this is going to go. Once again, be sure to write it in little endian notation. After this, you are going to write the length of the file plus 1. So it would be what the next number would be at the end. After this, you're just going to leave the header alone and leave all of the rest of the numbers to be 0. The only part I'm not sure on this is the value at 0x18, which is the loop end sample. I think that's right, and it seems to work in game, but I still might be wrong on that. So once we have all that data saved, we can close our hex editor, and we're going to right-click the file and go to its properties, and we're going to change its file extension from .ima to .hwas. If you're just planning on completely dumping the hex straight into the ROM without testing it first, you don't have to do this. But for me, it's really easy to test it using VGMGUI, but that program only recognizes files with the extension .hwas. The next portion is a bunch of trial and error. So VGMGUI can accurately listen to a decoded version of this HWAS file, but I sadly can't use it to encode it. Once again, if you can look at the way that it decodes it and figure out how to encode those 4-byte headers, please do that. But because that we're missing those 4-byte headers, the audio is inconsistent and doesn't really work. So what I've done is I've written a script that inserts a static header every 0x8000 bytes, and this makes the audio more listenable and easier to hear, but it's by far from perfect. If you want to experiment with the values, you can open up the file and change the bytes that are written. One thing that was noted on the Score Hero forum was that the least significant nibble always ended with a 0. Anyways, what we're going to do is we're going to put hwasfixer.py in the same directory as your song.hwas, and we're just going to run that via command line or your IDE once again, and that will generate a new file with a new name, and you can change that name to whatever you want if you really want to. If you want to go through the process of testing out different values, here's the workflow that I felt worked best for me. So you're going to have a Python IDE with the program open in one window. You're going to have VGMGUI open up in another window, and you're going to have a file explorer with all your files in it in a third window. You're going to run the HWAS fixer. It'll generate a file, and then you take that file, drag it into VGMGUI, and then click on it, press play, see if it sounds okay, and then you're going to press the stop button, right click, and then remove it, and then just try again with other values. Once again, the script that I wrote is a temporary fix, and so once it's discovered how to encode those 4-byte headers, there will be an update in the description and in the comments. Currently, what I know about the 4-byte header is that it's some kind of step size index or predictor. Anyways, once you have this HWAS file, that means that you have the data needed to finally insert into Guitar Hero Modern Hits and create custom songs. Alright, so we have the chart file and we have the audio file. We are in the endgame. All we have to do is copy the hex code and paste it into the correct spots in the DS-ROM. So how do we determine where we can paste it in the DS-ROM? Well, it all depends on file sizes. In order for a chart to work, it must have a smaller file size, both compressed and in the decompressed version. This only matters for the chart because the audio is already decompressed. This decompressed size is stored somewhere inside the fs-index.bin file, although I have not been able to find out how to navigate that file, and neither did any of the people on Score Hero. So if we want to get customs that are longer in length and have longer charts, we are going to have to investigate that file, as well as the file allocation table and the file name table, because once we insert a song's hex code, if it moves the hex code of any other song, then that changes the offset of it, which screws up where the file name table and the file allocation table point to. The process for this is fairly simple. You're going to want to choose a song to replace that is just barely longer than your choice of song, and whose chart is also larger. A tool that I thought about writing would be a table containing all of the file offsets and lengths in order to aid you in deciding which song to replace. This process would also probably be fairly easy to automate, given that these file offsets are static. Then you're going to need to open up Crystal Tile 2 again, open up the ROM, and click the little DS icon so that you can look at the file sizes and offsets. Towards the bottom of this list are the song files, and there are also the chart files. You're going to be looking for your song expert, because experts have the largest chart file sizes. If you don't want to bother with any of this calculation, you could always replace Shockwave or Call to Arms, which are the longest and largest files in the game. So anyways, now we are going to open up our favorite hex editor and go to the offset of the file that you are going to replace. What we are going to do is we are going to paste in the hex code to overwrite that file from the beginning of that file's offset, and we're going to go to the end of that file and select the block of bytes starting from the byte after the file that we inserted and going all the way to the offset before the beginning of the next file. And then we're going to fill that selection with zeros. What this does is it prevents us from having to deal with the fs-index.bin and the file allocation table, file name table, whatever deals with the offsets and how much memory to allocate to the decompressed files. You don't have to change it anymore. So once you get that information pasted in for both the chart file and the HWAS file, congratulations, you have a ROM of Guitar Hero on Tour Modern Hits with customs. So, yay, we have customs on Guitar Hero on Tour Modern Hits now. Although this is a large milestone, this doesn't mean that the project is done. Consider this a call to arms to the community, as there is a lot of work that still needs to be done with this. Star power, sustains, and forced hopos need to be implemented into the chart creation script. A block header encoder needs to be written to fix the volume of the HWAS files. And, in general, this whole process can be more automated. Furthermore, there are plenty of in-game bugs that I've come across that don't really have much of an explanation. Namely, the game sometimes thinks that the chart files that you put in have the same amount of notes as the chart that it replaced, and so it decides to insert a couple hundred broken notes at the end of the chart. It's a fun time. In addition to this, editing section names can also be explored. There's a file that you can see in Crystal Tile 2 called like sections.qb or something like that. Edit the hex code, see what happens in there. You can decompress it with dsdcompgh. And finally, here's something that you might have noticed that was missing that I'm putting here at the end for everyone that watched this far through the video. To edit the appearance of the name of the song in game, you need to search for the name in the hex code and edit the metadata that shows up there. You'll be able to see the song name and the artist name and the bio information. So if you edit that hex code, that's what changes the appearance of the name of the song in game. So, on to the too long, didn't watch for all the people that skipped there. Alright, here's the quick version of how to import customs. Put your file in the same folder as convert.py and chparse and run convert.py. Open Crystal Tile 2, go to Tools, LZ77 Compression, select the new file and save with the default compression. Then, hex edit the compressed file, pad with 00 until the length is divisible by 4. Remember that new length, insert the 5 bytes 4C, 080045, and then the 3 bytes of that file size plus 8 in little endian hex notation at the beginning. Now, take your audio and open it with Audacity. Set the project hertz to 19,996, resample it to 19,996 Hz, mix it to mono, save it as a WAV file. Then, run sox song.wave song.ima. Open IMA file in your hex editor, insert 512 bytes of 00 at the beginning, and then follow this guide on what to put there. Save it, and then put it in the same folder as hwasfixer.py and run that. Now, open your legally obtained ROM, go to this offset, and overwrite with your hex data for the chart, and then overwrite following that with zeros until this offset. Do the same thing with your audio for this offset and this offset. Save your ROM, ta-da. Guitar Hero, onto our DS, custom songs. I put a ton of time into making this work, and so I'd really appreciate it if you liked and shared this video if you enjoyed it, and subscribe if you want more Guitar Hero content and updates to this DS ROM hack project. Please let me know if you have any questions at all. I'll be sure to answer them in the comments, or feel free to DM me on Discord as well. That'll be in the description. Furthermore, if you're able to and willing to lend your help to this project, you can commit to the GitHub I've linked, or DM me with other ideas. The scripts that I've written will be open source, and I'm also linking all of the documentation that I found in the description. Thank you for watching, and have a nice day. Good luck